Okay, I've never moderated a session that I have to introduce myself. Somebody suggested this morning that I introduce myself. I think I said I was going to introduce myself and walk off the stage, get back on. I'm going to be talking this morning about load ratings and postings and the impact that we've seen in specifically in Oregon as a result of these load ratings for specialized hauling vehicles and emergency vehicles. I want to first give acknowledgement to the ODOT load rating staff. None of those folks are here today, but John Rupert, who's the senior load rating engineer at ODOT, was just super generous with his time and information in providing some detail for me to relay to the group. So any errors in judgment or fact are attributed entirely to me and not to ODOT, certainly. A brief overview of what we're going to walk through here. I'm going to hit some really quick load rating background. If you've seen some of the other presentations yesterday, Travis had some load rating stuff. Bill Oliva had some load rating stuff and some strengthening stuff. I think we've seen a lot of this background information, but I want to hit it real quick just to set the stage. But then I want to get into, okay, what's really the big problem here for bridge owners and the most recent load ratings that we've been doing. Talk a little bit about ODOT's load rating program itself, just from a framework point of view. And then, okay, what happens when we get what I'm calling poor load rating results, essentially whenever rating factors dictate that a bridge needs to be posted or permit restricted. So many of you know what this document is. It's the metrics for the NBIS. Metric number 13, it comes out of the 23 CFR 650 subpart C. Bridges are rated for their safe load carrying capacity in accordance with the AASHTO Manual for Bridge Evaluation for all legal vehicles and state routine permit loads. So we have to load rate NBIS bridges. These are the traditional classical trucks that many of you are familiar with, the Type 3, 3S2, and 3.3. ODOT does bump up their Type 3 and 3S2 slightly beyond what the AASHTO trucks are, but these are a 52 kip truck and then 280 kip trucks. Then in 2013, we had the memo from FHWA to clarify the load rating requirements for specialized hauling vehicles, or SHVs. It grouped it into two different categories. So your Group 1 bridges were the maybe worse bridges. These were due by the end of 2017. Group 2 is due by the end of next year, 2022. Basically, Group 1 bridges, bridges with rating factors of less than 1.3 for your traditional Type 3, 3S2, and 3.3 loads. It's kind of a screening. Many of you have heard, SHV Group 2, SHV Group 2 deadline. That's next year. What are the specialized hauling vehicles? This is the SU4. It's a 4-axle heavy hauling truck. SU5 is 62 kip truck, and we just keep adding axles and length and weight to our trucks. SU6 and the SU7. These are all legal vehicles on our roads that we have to rate bridges for now. Then we have the notional rating load, the NRL. ODOT does not use this. A lot of states do as a screening load. If this passes, then you don't have to rate the 4 SHVs. Then fast forward to 2015, and we have the FAST Act, the Fixing America's Surface Transportation Act. This is when we got into emergency vehicles. Now, for emergency vehicles, the first caveat is it has to be on an interstate or within 1 road mile to or from the interstate. Some states have decided to just rate all their bridges for emergency vehicles because they're doing it anyway. Again, we have two groups, but this one's backwards. Group 1 is good. Group 2 is bad. Group 1 is inventory rating factors for HS20 greater than 1.0, HL93 under LRFR greater than 0.9, Type 3 truck greater than 1.85. If you meet those criteria, you can re-rate the bridge for emergency vehicles whenever a normal re-rating is warranted. Group 2 is worse, got to be done by the end of 2019. Some states are on plans of corrective action. Maybe they didn't make that deadline, but that was the official communication in 2015. So what are the emergency vehicles? Well, they're very heavy over short wheelbases. You're talking about a 57.5 kip truck over 15 feet, or an 86 kip truck over 19 feet. Heavy, heavy axles. 62 kips in tandem on the EV3. You can imagine for short spans, this truck very often controls. So what's the big problem here? Well, it's concentrated loads. It's these heavy axles. Let's look at the Type 3 S2. This is our standard tractor trailer. We're over a 51-foot wheelbase, and we're at an 80 kip truck, very standard truck on the interstate highway system. Now look at our EV3. We're an 86 kip truck, so heavier truck over a 19-foot wheelbase. Not only that, but again, that 62 kip tandem is just killing our bridges. So here's a picture on the left. We have an SU5, 62 kip truck over 22 feet. And on the right, we have an EV3, an 86 kip truck over 19 feet. So the rear tandem axles of the EV3 are the same weight as the entirety of the SU5. Very heavy. ODOT's load rating program, how is it structured? What does the framework look like? Well, 7,007 bridges in Oregon that either states or local agencies own and maintain. 2,760 of these are state-owned bridges. This is a graphic from their bridge condition report. Over 800 bridges approaching end of service life within the next 20 years. This message is echoed in many other states as well, just a growing inventory of preservation and replacement needs. So I wanted to go through, okay, how big is ODOT's program compared to other area neighboring states? So Washington is 8,338. Now this information is from the InfoBridge portal, so there may be some error. This also includes bridges that are located in these states that may not necessarily be owned and maintained by the state or local agencies, like federally owned and maintained and inspected bridges. Idaho is at 4,522. Utah is at 3,000 and change. Let's come here to Arizona, 8,428. And then just for grins, California, wow, 25,763. So that kind of gives you an idea of what Oregon's inventory looks like with respect to other area states. ODOT has a really strong internal staff of load rating engineers led by John Rupert, who's their senior load rating engineer. But the vast majority of the load ratings that are coming out of Oregon are through their consultant partners. Those partners I've listed those partners there. We have several different on-call contracts that are all based on bridge types. So you go all the way down the list. Towards the bottom, you've got refined analysis, and I'll talk about that towards the end of the presentation. There's also a management and staff augmentation contract. There are several contracts where we help the department scope load ratings, new work order contracts for other consultants. Can't scope our own bridges or assign our own bridges. Review bridges that are load rating packages that are put together by other consultants, and just any other type of staff augmentation work that ODOT could potentially need. We have some poor load rating results. We know that. We're rating for these heavier vehicles. Now, what's next? How does ODOT respond? Well, ODOT has a flowchart, as we like to put together flowcharts, and the previous version of this flowchart was 2 pages. That has since been revised to a 15-page flowchart. Now, I've shown the first 2 pages of the flowchart here. John told me that I should throw up all 15 pages of the flowchart and watch everybody's eyes glaze over. Your eyes are probably glazing over anyway. The important thing to note here is that there's a very, very specific decision matrix for the acceptance of load rating packages. The key thing to note here is, you go down the list of questions, and if the bridge is in if the bridge is the rating factors are not above 1, you go to this level 2 assessment on the next sheet, and then the next question is the bridge owned by ODOT or not? And if it's not, it goes to a local agency review. So it stops right there. If it's a local agency bridge, it goes to the local agencies. Now, if it's an ODOT bridge, you start asking more questions. Is it a primary route? Is it interstate? And then the decision kind of branches from there. But that first question about whether or not it's a state-owned bridge or a local agency bridge is key. For state bridges, they're either going to be rated in-house or by a consultant. Typically, all the time, part of the scope is a full QC on your load rating package. So you're QCing all of your load rating packages anyway. That's standard. You get to the end of your QC and you have some low rating factors. Well, there's always some pencil sharpening that can be done. We always love that term, pencil sharpening. And it's funny how that has become like a technical term. Like we'll get a load rating finished up by one of our load raters or something, and rating factors are 0.85 for the SU5. And I say, well, have we pencil sharpened yet? That's like an official term now. So there's always some pencil sharpening that can be done. Load rating in and of its own nature is you use conservative assumptions initially to get through the process efficiently. So you document those assumptions, and when you come back and you get low rating factors, you know exactly where to refine some of those assumptions. So that's done. That's always done, and that's done before on the consultant side. That's done before the package goes into ODOT. Once that package goes into ODOT, then you have to make some decisions on whether or not refinements need to be made or can be made. For state bridges, ODOT has a lot of different levers that they can pull for refinements. I mentioned the refinement price agreement that they have, that they can package up refinements and send it to a consultant and say, this is what we want you to do, either a grillage model or refining your live loads or even as far as instrumenting and load testing something. We also have quite a bit of leverage in terms of contingency scope that we can utilize on particularly some of the more complex load ratings that we do, where we can say, well, this is what we're getting. It's because of this live load thing or this capacity thing, and if we do this, this, and this, we can refine it. And they say, yes, that's good. Go do that, and give us a budget for that. So that's another lever that they can pull. They can also go down their own internal, once we submit the package, they can go down their own internal flowchart and decide how they want to proceed with it. But there's a bunch of different options that ODOT can utilize there. Now, local owned bridges are a little bit different story. It's more difficult to officially refine local agency owned bridges because ODOT has, now again, we're always going to be doing our full QC, we're always going to be doing our pencil sharpening. But ODOT has a specific, number one, they have a process and framework in place for refining state-owned bridges, and they have a specific budget set aside, a pot of money set aside specifically to refine state bridges. They know that this is going to be a problem, and they set that money aside. Now, I mentioned that ODOT manages the load ratings for all local agencies, and that's as far as they go with it. They manage the program for locals. So they have a pot of money, and they have a group of bridges that need to be load rated for the locals, and they do it. Beyond that, the locals have never set aside either a procedure for refinement, like priorities of bridges and what routes and what types of refinements to do, or a budget to actually do that, which makes a lot of sense, right? It would be very difficult for all of the counties and cities in Oregon to get together and say, this is our framework for refinement. They all have different interests and priorities. ODOT pretty much stops right there when it comes to poor load rating results for local agency bridges, and they package it off and they send it to the local agency with a posting letter, a little bit of context narrative on why the bridge is rating out low and what options the local agency has. So we talk about refinements, and I think one of the questions was asked during Bill's presentation, the local agency strengthening presentation yesterday. What kind of refinements can you make? You got two sides of the load rating, or two key parts of the load rating equation. You have your capacities and your demands, either your dead load or your live load demands. So you can try to increase your capacities or decrease your demands. And there's so many different ways that you can go about doing those things. I've listed just a handful here. So many times we have old steel girder bridges that we assume are non-composite. Maybe we don't have any records indicating that they're composite or that we have shear studs. Sometimes we can get those records from the local agencies. Sometimes there's some institutional knowledge there that we can use. Heck, we've even gone in and potholed old country bridges to see if there's shear studs, and lo and behold, there's shear studs on these old bridges. And so we can rate them as composite. Material properties, we can find construction documentation that verifies better material properties. Lateral torsional buckling is a huge thorn in the load rater's side. We can do some finite element modeling to try to predict or at least verify that lateral torsional buckling would control, and if it doesn't, then we can change our models. Condition factors and system factors, there's let's say we've got we're rating a truss, superstructure's a 4, but it's a 4 because of some really bad stringer deterioration. We're rating the truss is in great shape. We can justify increasing our condition factor to take that into account. System factors, we can take into account redundancy of the system. The MBE allows you to go up to 1.2 on your system factor if you can justify it, if you can calc it. So that's a potential. And then just field measurements. Sometimes many of us that load rate know that the information that we have from some of these local agency bridges that were built 60 years ago plus can be very poor. And so sometimes it's just a matter of going out there and realizing that, hey, we've got diaphragms, or we've got the owner welded on cover plates 25 years ago, or something like that. Conversely, we can refine demands as well. Head loads are fairly simple. We can do some investigation to determine our asphalt wearing surface thickness. Live loads are usually the second place we go. The first place we go is capacity. The second place is live loads. Again, Bill mentioned in his presentation, live load distribution factors are inherently conservative per code, and so oftentimes we can justify reducing those live load distribution factors either through grillage models, 3D models, things like that. So just a few examples of some bridges in Portland that we have experience doing some refinements on. I'll hit these fairly quickly. Each one of these could probably be its own presentation. In fact, I think the St. John's Bridge in Portland was its own presentation at Western Bridge a few years ago. But this is the Markham in downtown Portland. It carries I-5 over the Willamette. It's kind of like the redheaded stepchild of Portland bridges. I think it's a cool looking bridge, but people in Portland seem to like the other ones a lot better. It's a double deck truss. So this one we had low rating factors for permit loads, for state permit loads. On the top deck was controlled by negative moment in the continuous stringers. It was lateral torsional buckling, laterally unsupported compression flange in the stringers. Normally when we load rate bridges, the first thing that I teach like younger load raters is, they come to me and HL93 is 0.6. Okay, well, okay, nope, no big deal. Type 3, what's your type 3? What's your type 3S2? What are your SHVs? And so this bridge, it was all the legals were above 1, and the permit loads were, a couple of permit loads were less than 1. And I thought, this is going to be a problem. We can't permit restrict bridges on I-5 going through downtown Portland. ODOT's not going to be happy about that. So what they had us do was a buckling analysis, a finite element model. Basically generated a finite element model for the girder. Applied load to it to get the first, I think, 3 modes of buckling. This is the first mode of buckling shown in plan view, which corresponds to LTB. Calculated the load to get that form of buckling, compared it to the load to get yielding, came up with a safety factor of 1.53. So through that, we were able to justify updating the brass model for the stringer to laterally support the compression flange and force it into yielding instead of buckling, and that eliminated the the low rating factors for permits. This is the Hawthorne Bridge, also in downtown Portland. This is a local agency-owned bridge. Multnomah County owns this. It's I believe it's the oldest operating lift span in working movable bridge in either the United States or North America. It's 1908, I believe. Super cool bridge. This one had also low rating factors, but for positive moment in the stringers. This is a steel grid deck bridge, so there's not a whole lot of lateral support for the stringers. Very similar process here. We did a buckling analysis. This was a little bit different though, because this is not a state bridge. When ODOT got the rating factor results, we were getting some low rating factors for SHVs. They communicated that with Multnomah County. Multnomah County waited for the rest of the bridges in this complex to get rated under several contracts. Once they realized that the Hawthorne had the controlling rating factors for the whole complex, they said, okay, can we do some refinements? And we had some contingency scope that we could do some refinements on this one. The St. John's, I loved Chris's presentation about stiffening trusses. Stiffening trusses they really make you scratch your head. This was a bridge that we had low rating factors all over the place, but predominantly in the stiffening truss. And so what we ended up doing was we knew that this bridge was going to need strengthening, but we also knew that if we could eliminate the stiffening truss members from the strengthening scope, we could probably eliminate 50 to 75% of the scope. Through and did a redundancy analysis on the stiffening truss itself, where basically we just used a combination of linear analysis model and a nonlinear analysis model to fail a handful of members. These are the members that we looked at, a handful of members that were rating out low, and see how the loads redistributed. And because it's a stiffening truss and you had all of those suspender cable connections, loads were able to redistribute past the failed member without any increase in load on other members beyond their elastic limit. This redundancy in highway bridge superstructures talks about this. This is from way back in 1988. And the MBE allows you to go up to 1.2 if you can justify it. So we justified it, went up to 1.2. And we're able to eliminate those members. How do we communicate this to the local agencies? Well, this is the kicker. I mean, look at these numbers: 178 posting letters sent to locals in 2019, 176 in 2020, and in 2021, 303 posting letters. Now, this is very direct and targeted communication to local agencies, and you can see what kind of a political and an outreach issue this can be. On the state side, they've done their own strengthening in-house. They've done some refinements in-house. Consultants have done refinements under their contracts. Wisjani has the work order, or has the price agreement for refinements. They've refined 176 structures since August 2017. So you can see the impact of what we're talking about here. Quite a bit of work just to communicate, strengthen, refine, or post. So the outreach to the local agencies is critical. ODOT created a flyer, I think last year, that really talked through, okay, what does this mean? How heavy are these loads? Why do we need to rate these bridges? Why, as Travis likes to say, once we rate it, if we don't post it, it's going to turn into a pumpkin and collapse, right? What's the reasoning behind why we actually need to do this? And that's been a big part of ODOT's program, honestly, for the past couple of years, is just that outreach to local agencies. So in summary, the impact of load ratings for SHVs and emergency vehicles has been huge and will continue to be huge, both for the state and for the local agencies. ODOT does administer all the load ratings for NBIS bridges in the state, including local agencies. Consultants do perform the bulk of the load ratings. Poor load ratings for state bridges, they've got some options. They can refine in-house or through consultant contracts. They can program strengthening projects. Local agencies must post their bridges based on direction from ODOT. Local agencies then have the option to use in-house expertise, which some counties have, some cities have, or consultant contracts and consultant relationships to refine their poor load ratings if they want to avoid posting. And the outreach from the state to the local agencies has become extremely important. Time for one question, if anyone has. Okay, that's the first hand I saw. The question was, has ODOT actually found EV3s in their inventory? Are the trucks actually out there? I don't know the answer to that question. Thank you.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.